Why is the stratosphere cooling with global warming? Imagine a layer high above us that is getting colder even as the planet warms. It sounds strange, but this is exactly what scientists observe happening in the Earth's atmosphere. The reason behind this counterintuitive trend involves two main processes. First, greenhouse gases like carbon dioxide are trapping heat in the lower part of the atmosphere, called the troposphere. When these gases increase, they absorb more infrared radiation from the Earth's surface, preventing it from escaping into space. This causes the troposphere to warm up. But because more heat is held below, less of it reaches the upper layers, making the stratosphere cooler. Second, ozone in the stratosphere plays a big role. Ozone absorbs ultraviolet radiation from the sun, turning it into heat and warming the layer. When ozone levels drop, less ultraviolet radiation is absorbed, so less heat is produced there. Plus, ozone itself acts as a greenhouse gas in the stratosphere by trapping some infrared radiation. Fewer ozone molecules mean less heat is retained, which cools the layer further. This pattern of warming in the lower atmosphere and cooling in the upper atmosphere is a clear sign of human influence on climate change. Natural climate variations do not produce such a strong opposite trend between these layers. The cooling of the stratosphere is also confirmed by satellite data collected over the past few decades. It shows that, as carbon dioxide levels rise, the upper atmosphere contracts slightly, which can affect satellite orbits and space weather. Understanding this cooling is important because it influences the amount of water vapor in the stratosphere, which is a potent greenhouse gas. Changes in temperature here can impact how heat and moisture move around the planet, affecting weather patterns and climate systems worldwide. This cooling pattern is a key piece of evidence that human activities are altering Earth's climate in complex ways beyond just warming the surface. It highlights how interconnected different parts of our atmosphere are and how changes in one layer can ripple through the entire climate system.